Okay, so we're going to look at an example using work. All right, imagine you lift a 50-kilogram sack of flour 2 meters up onto a shelf. Your friend lifts a 25-kilogram sack of flour 4 meters up onto a different shelf. During the time you're both moving the sack up, which one of you does more work? All right, so we have you, and it says you have a 50-kilogram sack of flour, and you're going to move that a distance of 2 meters. Your friend has a 25-kilogram sack of flour, and they're going to move it 4 meters. So what is the difference in the work? Well, let's remember for both of these cases that work is equal to the force in the direction of the displacement. And we're lifting these up so we know this is all in the vertical direction. How much force do we have to apply to lift a 50-kilogram sack? And it tells us that we're lifting it up by let's think about it as a constant velocity. Well, we know that we have to apply a force equal to the force of gravity to lift the sack up. So the force that we have to apply to our 50-kilogram sack is going to be 50 times 9.8. Well, 50 times 9.8, that force is 490 newtons. And the force that my friend has to exert, well, that's 25 times 9.8, the weight of that sack. And that force that she has to apply is 245 newtons. So we know the force that each of us has to exert. Now let's look at the work done to lift it, those 2 meters. So the work I have to apply is my force times the displacement, or 490 newtons, times 2. So that work is 980 joules. My friend, well, they have to apply a same relationship, force times that displacement. Well, their force is 245 newtons times 4 meters. Well, that's 980 joules. So for both of us, even though we're going different displacements, because we have different amounts of force that we're doing, we could still apply the same work. So just utilizing our work relationship, that force times a displacement, and a little bit of practice. All right, good job.